So 5.3 is standard deviation. So that's a new term for us in this section. We need to use the term mean, which we're familiar with from our beginning of this chapter. Mean is the average. So here, if we look at a formula for mean, we're familiar with how to find the mean. This symbol is new to us. This symbol stands for sigma, which just means sum. In order for us to calculate the mean, we need to add up, we need to find the sum of all of our terms and divide it by n, which is the number of terms that you had. So far here, nothing new. Standard deviation, which is a measure of the extent to which data clusters around the mean, we need to use the mean in this formula. These symbols here, these fancy U's, is where we're going to substitute in the mean. This U equals an X with a line over top of it. That symbol is interchangeable, and I will often use this symbol before the U. So if you want, you can rewrite that formula. Square root of the sum against sigma. Sum of your data minus the average, or the mean, squared, divided by n, which is the number of terms. So that's the formula we're going to be using in order to calculate our standard deviation. The smaller the standard deviation, the more consistent the result and the closer the data to the mean is, sorry. Example 1. Calculate the standard deviation from the following sets of values. So our first step that we want to do is calculate our mean, which is our X with the line over top. And we're familiar with doing that. We add our data all together and divide by the number of terms that are there. So 7 plus 8 plus 9 plus 10 plus 11 is 45. Divided by the number of terms, there's 5 numbers there, which is 9. So our mean, our average, is 9. That's going to be this part of our formula right here. The next step we want to do is determine our deviation. So deviation is our term minus our average. In other words, how far away is that data number from our mean? For instance, let's use 7. How far away is 7 from 9? 7 minus 9 equals -2. Our data term 7 is 2 numbers less than 9 is what that's telling us. So in our formula, standard deviation, we'll have our square root. Sigma tells us we want to add up all of the deviations, so our data minus our average squared. We want to add all of those terms up and divide by the number of terms that we have. So 7 minus 9 squared. That's our first term with our deviation. Plus, since we're finding the sum, 8 minus 9 to find the deviation of that term, squared. Plus 9 minus 9 squared. Plus 10 minus 9 squared. Plus 11 minus 9 squared. And our square root sign wants to go all the way to the end. Divided by n, our number of terms is 5. So we'll write it like this. To simplify, 7 minus 9 is -2 squared plus -1 squared plus 0 squared plus 1 squared plus 2 squared, all divided by 5. Even further here, we have the square root of 4 plus 1 plus 0 plus 1 plus 4 divided by 5 equals 10 divided by 5, which is the square root of 2, which gives us 1.41. So our standard deviation is 1.41, which is a smaller number, which tells us these numbers must be pretty close to around 9, all of them. None of them are too far away because we have a smaller standard deviation, which means the data is more consistent. It's closer to the mean. Next example, B. We have data number 7, 9, 11, 13, and 15. So our first step again, calculate the mean. Add up all of your data and divide by the number of terms. So our mean is 7 plus 9 plus 11 plus 13 plus 15 divided by 5 terms. Gives us 11. Plugging that into our standard deviation formula. Standard deviation is the square root of each deviation, so the distance away from the mean for each term squared, divided by the number of terms. So we have 7 minus the mean, which is 11. 7 minus 11 squared, plus, we're doing sum again, 9 minus 11 squared, plus 11 minus 11 squared, plus 13 minus 11 squared, plus 15 minus 11 squared. Make sure your square root sign covers all of your terms, all divided by 5. We'll simplify that into another step. 7 minus 11 is negative 4, so square root of negative 4 squared, plus 9 minus 11 is negative 2 squared. Plus 11 minus 11 is 0 squared, plus 2 squared, plus 4 squared. Again, all divided by 5. Applying our squareds is 16 plus 4 plus 0 plus 4 plus 16 divided by 5. Simplifies down to 40 divided by 5, which is the square root of 8, which is 2.83 as our final answer. As you can see, compared to our last example, the standard deviation is slightly larger, which means these numbers must be a little bit more spread out from our average of 11 compared to the numbers spread out to 9 in our first example. So again, the smaller your standard deviation, the closer your numbers are to the mean. The larger the standard deviation means your numbers are that much further away from your mean. Example 2. Calculate the standard deviation for the following sets of data. For part A, so what we see that's new in these examples is we now have a range of data on the left side of our table compared to one piece of data on the right-hand side. So when you're given a range, when we're looking at 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and so on, you want to use the mid value of these ranges. So find the mid value of each range and use that for your data points. So the middle of 0 to 10 will be 5. The middle of 10 to 20 is 15. The middle of 20 to 30 is 25, 35, and 45. Those will be the points that we are going to be using in order to calculate our standard deviation. So a reminder, use your middle value. to find the mean. Okay, so now our first step again, step 1, is to calculate your mean. So our data with a line over top is our average, or our mean, equals 5 plus 15 plus 25 plus 35 plus 45 divided by our 5 terms. $535 Sorry, I just erased that quickly. When you have your number of employees 4, so looking here, number of employees 4, 9, 6, 4, and 2, those are the numbers of times that each daily commute time occurs. So when we're going to find our average, we would go 5 plus 15 plus 25. We need to actually multiply by the number of times that's happening. So the number of employees that travel 5 minutes. So 5 times 4 plus 15 times 9 plus 25 times 6 plus 35 times 4 plus 45 times 2. That is where we'll get our 535 divided by the number of terms we have is 5.